Hello everyone, and thank you for joining this webinar about Aplitop TcpMDT on GstarCAD. This webinar together is done in collaboration with eDisti, our dealer in Slovenia. And first, we will see a short presentation of this company of eDisti done by Primos. So please, Primos, whenever you're ready, let me know and I will give you the control so you can share your screen.
Okay. Thank you, Hugo. Thank you, Antonio. Dobrodošli na webinarju, ki ga pripravljamo skupaj z podjetjem Aplitop iz Španije. Samo trenutek. Ja, danes bomo, se pravi, jaz sem Primož Kubic, prihajam iz podjetja eDisti, kot je bilo že prej omenjeno, se pravi eDisti Ljubljana. Mi se ukvarjamo z prodajo in se pravi skrbništvom ključnih strank, med drugim se pravi tudi z CAD rešitvami in BIM rešitvami. Smo prisotni ne samo v Sloveniji, tudi na Balkanu in v Angliji oziroma v Veliki Britaniji. Danes bomo izključno, se pravi, govorili o programu Aplitop, ki ga predstavljamo sedaj za slovensko tržišče. To pomeni, da sicer v podrobnosti bosta bolj kolega iz Aplitopa povedala, kako se z samo programsko rešitvijo uporablja v kombinaciji oziroma znotraj GstarCAD programa. Tako da danes se bomo fokusirali na praktičnem delu bolj na geodezijo. V prvem delu pa bo omenjeno splošno vse, kar sam Aplitop program omogoča. V planu imamo tudi, da čez 14 dni naredimo zopet webinar, kjer se bomo fokusirali na ceste in potem, se pravi, čez 4 tedne na železnice. Jaz bi za uvod imel toliko, tako da vkolikor bodo kakšno vprašanje potrebna, se vklopim na koncu, tako da prepuščam besedo Antoniju Hugotu. So Hugo, you can start it, or Antonio, please.
Okay, thank you, Primos. Thanks everyone for attending. My name is Hugo Perea. I'm in charge of the international sales of Aplitop. Aplitop is a company which develops software for civil engineering and topography, and it's present in the market for more than 30 years. It's a Spanish company, but we offer our licenses in more than 75 countries, and there are over 18,000 surveyors or civil engineers in the world who are using our products. Our main products are digital model terrain tools for surveyors. We call it TcpMDT, and we have 3 modules. The TcpMDT standard is for surveying, profiles, volumes. Then we have the TcpMDT professional, which includes specific functionalities for roads design. And then we have the module of TcpMDT surveying that allow us to coordinate the system and do observations. Those are the products that we'll see today on GstarCAD. We will do a demo of TcpMDT on GstarCAD, and you will see how to work on a project using our tools on GstarCAD. Besides the TcpMDT, Aplitop also develops field applications such as software for Android or Windows that works on those devices, Android or Windows devices, and connects through Bluetooth to the antennas, to the GNSS antennas. So you can go on field and take points, and then with those points you can develop the digital model terrain and work with the TcpMDT. Besides the field application software, we have also photogrammetry and point cloud applications. Specifically, I would like you to test the point cloud software, TCP Point Cloud Editor, which is also available in our website. You can also have a free demo of this. This is a standalone software, so it means you don't need any other CAD platform or any other program to run it. This is a standalone software, and it allows to edit and filter big point clouds of data. That's to prepare the point clouds to be modeled and to be prepared to do some digital model terrain works on it. And last but not the least important are the tunnels software from Aplitop. We've developed different software for total stations, scanners, and for desktop. So you can track and check inside the tunnel how the excavation is going, and then you can modify the design or check the design on the desktop about this excavation. So those are the products from Aplitop, and just to mention, we have been awarded by different organizations because of our innovation, our innovative work. Constantly we are developing new solutions. We've worked to do products research in the augmented reality, virtual reality, or BIM sectors. So if there is any functionality that you're missing or you like our products like TcpMDT to have, just to let you know that we have the knowledge, we have the muscle to develop new functionalities. So you can contact us through Primos, through our dealer in your country, and let him know, hey, we would like to have this new functionality, because Aplitop is able to develop it. Okay. Here we have some case studies. As I mentioned earlier, Aplitop is present in over 75 countries, and our software has been used in New Zealand. This is MDT software which was used in a 18-kilometer road in New Zealand. Also, our software has been used in Ottawa, in Canada. Also, the digital model terrain software is this is the MDT, the one we'll see today, has been used in Sweden to prepare the terrain, to install some solar modules, or also in Texas, in the United States, to design the North Taran Express, a highway crossing the state of Texas in the USA. All those case studies with more information are available also in our website, also with the contact details of the project managers. So you can email them and ask how was their experience with our software, and they will tell you in first hand how much time, how many resources they saved thanks to using TcpMDT in each project. Among our main customers worldwide, you see here a hint that are the biggest and main construction companies all around the world. So just to have a brief look on that. And among our partners, as I said, we develop software for total station, GNSS antennas, scanners. So all the main manufacturers within this sector are partners from Aplitop, and also for CAD. Today we are presenting this TcpMDT on GstarCAD, which is our software, our partner in CAD software. This is our sales network. It's present in more than 75 countries, and I like to mention our support, which is renewed by the 98% of our customers, because we offer the permanent licenses of TcpMDT. But every year you can renew the maintenance contract. That means it gives you access to our engineers to answer any questions, to give you support, remote support, to connect to your computer, everything you need to help you with the projects. And also we have the Academy, which is an online repository of videos. All of our videos are on YouTube, so you can easily find all the functionalities from our software. You can filter and find all the videos explaining how to do any part of the project using any functionality of our software, and very short videos, 1, 2, 3 minutes videos that explain everything about how to use our products. So that's all from my side. This was just a short introduction to Aplitop. Now I will pass the word to my colleague Antonio Pardo, who is a topographer here in Aplitop, and has a very wide and extensive international experience working as a topographer. He has worked in many countries, and now he's in charge of the topography section in Aplitop, and he's going to develop this demonstration of TcpMDT on GstarCAD. So, Antonio, whenever you're ready, I will.
Okay, I'm going to share my screen.
Okay.
Can you see my screen?
I can see it.
Okay.
Okay,
Hi, first of all, hi everybody. I am Antonio Pardo, and I'm part of the Aplitop support team to help you at anything in the application TcpMDT. Today, I'll try to show you how to work or how to easy work with TcpMDT. For that, I'm going to follow two simple examples to show you how to work, to show you what is MDT and the toolbox that MDT offers us for working in our survey or even our civil engineer project, etc. We are going to start. I'm going to start with a simple example here in Spain to import one list of the point that I take in the field with my device. And then I'm going to, when I create the cartography, I'm going to pass another sample in the local region of Slovenia to show you the system coordinate system and etc. In local region nearly close to you. No? So I'm going to start. The first of all, I'm going to show MDT is an application that works in CAD like a GstarCAD. So mainly, the first thing, only to think that it's composed in two big modules. No? The basic module, standard module, where this module allow us to create a cartography from our point cloud or something like that to create every line, surface, profiles, cross-section, etc. And then the second one is the professional module, where we can follow the engineer, project engineer, civil project engineer, to follow one side, or maybe to give a different quantity takeoff or something like that. No, so I'm going to start to create a cartography from one list of the point that I taken with my device, but with my GPS, for example. No? I'm going to import point. Okay, in this window we select the format of our list of the point. In this case, has this structure, or maybe we can use different structure or different format. The AC well-known is format LAS is very useful, or maybe the lang XML, something like that. No, I'm going to use the generic format. It's very useful, and we can arrange the list of the point by levels. It's a characteristic of TcpMDT to classify the point in order to work easier with this list of the point. No? At the end, the more important thing is how to represent or how to draw the point and all the entity that this point means. In this case, I remark draw from the code in order to draw all the entity, punctual or linear entity, in order to relate to the code. For that step, I need to configure or setting up the code database. In this case, I select the code database. We can use different code database depending on the language, depending on the work, depending on some characteristic. You can use different code database. No? Then I'm going to show you this code database. Okay, I'm going to select the code database, and I'm going to select one scale to representation of the points. No, in this case, I select one scale to graduate the text height of the text. Okay, click on OK and select the list of the point. In this case, this. Okay, and right now it's drawing everything in order to the code. No, so as you can see, we can draw automatically everything depending on the code. For example, here we have a tree. I'm going to show the code that the code. For example, I'm going to open the view manager, the display manager. I'm going to show the codes. I'm going to hide the elevation and the name. Apply, and here is. Depending on the code, we can draw each element, each punctual element, like a street light, like a chest, or something like that, or even the linear entity like this, no? Or the road, etc. If we can see the list of the point, we have several options to manage the point. We can edit, we can move, we can change the scale, the representation, the color, etc. Move the elevation, etc. List point. We can select by different ways to work with this kind of the point. No? In this case, I'm going to select all. I'm going to show every point. We have the name, the X, the Y, and Z, and the code. The code is, for me, the more important thing to easy our work, is to save a lot of work in our office, because we can draw in everything automatically. Okay, if we have a survey with our device, we can use TcpGPS, is another application in the field, and we can relate the attribute in this point. For example, attribute, and we can show the metadata set of this point in order to the device, the geographic coordinate, the date of the acquisition of the date, or maybe the different query that we take each point. No, it's very easy. I'm going to OK, and so we can show that we have the layout of this drawing very easy with this kind of the point. In this case, for example, we need to rotate manually, for example, this strip lamp, but if we use, because we use only one point to draw the straight line, but we have with MDT use 2 or 3 points to give instruction to the software to scale and rotate this block. For example, this is one case when we use 2 points, or maybe we can use 3 points to get the same thing. No, so in this case, it's easy to work and save a lot of time to working in our work. Why is this? Because we have a code database. I'm going to show the code database. And here it is. It's like a translation, even the code that you use in each code, and how to draw in each element, punctual or linear element in this working in our surveying. No? So I'm going to show how to edit, for example, olive tree. I take this, we can show that this is a code is defined by 1 point. Maybe we can use 2 or 3 points, or maybe we can use a linear entity. So in this case, we select the code, the level where we are going to save the point. We are going to set how to represent by block in the top view, or maybe by another row in the front view to the profile, or maybe in the cross section, something like that. Or even we can use a 3D object to represent that element in the reality, virtual reality show. Even we can arrange all entity by layer, by color, etc. Okay. Okay, we can change, we can delete. Only to say that this code database we can edit here, or maybe it's a format like every file that we create with MDT is an active file that we can edit with one text editor. Okay, when we have a final drawing of our work, we have with MDT a lot of tools to facilitate us different options, like for example utility. We can show, for example, to draw, for example, the slope is one option. We can select the origin line and total slope, one kind of I'm going to select the reference line. And now we can select the different scale to represent the slope of the rod, no? Okay, and here is one option to do that, no? Or maybe we can remark maps. Sorry. Here. MDT maps. Sorry, I confused something. Well, okay, this is another thing. As you can see, we have work. We can work in 3D or in 2D. For example, if I move, for example, I'm going to change the top view, the orbit, for example. We can check that it's a work in 3D, and we have a lot of tools to work with this brick line to create or to transform in 2D or 3D. For example, I'm going to convert 2D, select all, okay, and we are going to change to move in the 2D, or even to create a 3D to pass in other side. Line, convert 2D, the same thing, okay, and arrange to rise the brick line of this. Or maybe we have a lot of tools to, for example, displace parallel in 3D is very useful tools to work with this, or something like that. No? It's an easy way to create a cartography with this application. So now, if I go to sorry, here is top view. So right now I'm going to pass to continue the demonstration with one sample in the local Slovenian local region. Is this, no? It's our one example that someone gave us to show the demonstration, and it's a survey that it's cartography or drawing with another software, I don't know. And we can work with this kind of the entity directly with MDT. Not only with points or from the point that you take of the device or something like that. We can use a cartography from different sources or something like that. No, so in this case, I'm going to create a surface to create a digital model to work and analyze the terrain in this case. In this case, I'm going to use MDT surface, create surface. I'm going to give a name, for example, TcpMDT, save, to replace. And now I'm going to tell to the software I'm going to use the point and some brick line, 3D polyline to arrange how to triangulate the surface. In this case, I'm going to select the layer. I'm going to share to load one file like this. And here is we have, if we use only MDT entity of MDT, the select layer are selected automatically. So in this case, I'm going to select manually to triangulate the surface. Okay. I'm going to use the criteria, the maximum length criteria, 50 meters, to graduate the length of the triangulation. I'm going to use Iceland to annulate or hide some area where there isn't a surface. I'm going to use the building. For me, it's very difficult to use the name of the Slovenian name because I don't understand exactly. I think this is a building. Okay, so there are a polyline close polyline. I am going to include 3D brick line vertices. When I finish to triangulate, I'm going to draw completely in 3D. Okay, and here it is. This is our surface. If I have a good profile, I can get a profile of this, for example, for here. This is our road. This is the terrain. We can exaggerate the elevation, okay, or even we can measure in that here, in the weight of the rod, for example, to evaluate the cross section, okay, or even we can draw in GstarCAD or something like that. I'm going to click on OK. Right now I'm going to edit a little thing, the surface. I'm going to delete some line. For example, this, only this is not good. Okay, something like that. Okay, and we can use a different tools after editing the surface to save or to log the contour of our final surface. For example, MDT, brick line, create brick line, find a boundary, and create a boundary. If we have, or if we need to create a surface, we can use the boundary in order to avoid the create another editing of the triangle ADC. Okay. So the best way to represent the topography with one digital terrain model is to create a contour line. For example, I'm going to create contour line, contour. In this case, we can analyze, we can have a look, evaluate the elevation of this work and use the interval to name the surface. In this case, we can use a palette color to represent the contour line, etc. Okay, and here is our surface. If you use the display manager here, we can deselect the surface to clear the chain. We have this work, no? So with this, we can continue. We can use a different work. We can use or transform to grids, or maybe we can use a different surface ADC. But right now, I'm going to follow to create a profile, longitudinal profiles and cross section. So for that, I'm going to create an axis and a horizontal alignment. For example, we can use the convert polyline to alignment to create our horizontal alignment. In this case, click on in this option. I'm going to convert that polyline in our horizontal line. Here it is. Ahora, sorry. Here it is. This is our name of this work. Save. And here it is. We are going to dimension of our horizontal line. In this case, I'm going to change, for example, 500. And okay. And here is our horizontal line. We have a lot of tools to create this horizontal line, not only this way. For example, alignment, we can draw alignment directly. We can use different elements to define the curve transition, the lines, etc. But this is an easy way to create that. So right now I'm going to create a profile of this. For example, MDT, profile, get profile. In this step, it's very important to say that we have a lot of commands that allow us to get several profiles from several alignment or even several surface at the same time. At the same time, to create several profile, only one click, with only one click. Okay. So we are going to get a singular profile. We're going to use our horizontal alignment. In this case, this. Okay. We have select the origin of the source of the data. Okay. We can change another source. For example, in this case, we are going to use the surface, the digital terrain model, or in other case, we can use only the layer to cut the brick line that are in this layer. For example, if we have a cartography that are the contour line in 3D, we can cut the contour line directly, even not to create a digital terrain. Okay, we are going to digital terrain model. Okay, we can to say to the software how to cut all the terrain, for example, all the cut, or maybe interval constant. For example, interval constant, but it's the same. And this is, for example, one useful thing. If, for example, if you work in electrical cable in the electrical line, you can create profiles parallel on the left and on the right at the same time with one equidistance. No? But in this case, we use this configuration. I'll click on OK, and here is how to represent the profile. I'm going to use this configuration of the numerical data. I'm going to say here the format, how to exaggerate the elevation regarding to the horizontal alignment. Okay, I'm going to create the horizontal. Here is our profile. For example, there are some tools to project some point in this profile. For example, MDT profile, we can drawing. I'm going to project, for example, polyline to this profile. I'm going to select, for example, in this case, this is the grade line, or maybe the asphalt line in the road. I'm going to project in this profile. It's very important to read the command line to follow the instruction of this command. No? For example, select terrain of the longitudinal profile. I'm going to select the terrain, and here is. I'm going to say what is the horizontal alignment. File. And here is. This line, this 3D polyline project in the profile, or maybe we can use drawing, profile, drawing. We are going to project some points in this profile. For example, there are keyboard here. We can profile this. No, I'm going to project that point. This the cabla. Okay, I'm going to use this. I'm going to use this point to project in our profile. I'm going to use this point. For example, here there is 2. This point 2. Okay, here is. Sorry, I'm not selected the terrain. Select the horizontal line. I don't follow the instruction. Okay, I'm going to select the point. I'm going to select graphically. That's point. Sorry, is that point? That point and this point. Even this 3 point. Okay, 6 point that we are going to use. I'm going to select the block to represent this projection. I'm going to set to the number at the offset regarding to the horizontal alignment. I'm going to ignore the external point of the numerical data in the profile. And to OK, and here is our projection in this section. This is the cable over the rod. We can dimension to make a gauge control. For example, dimension, linear. We can use F3 like this, and here is 7 meter, 10 centimeter of the gauge from this cable. No, we can analyze some things like that. No, even the same thing we can get the profile, the cross section. The same thing we can cut the DTM. We are going to get the profile. We are going to use that horizontal alignment. We are going to save in this format, in this file, and we are going to use the current surface, our length of profile, and the interval to get the profile. We click on OK. Oh, sorry, I'm going to draw the cross section after getting the profile. Okay. Right now we are going to draw them in, for example, in this scale. To evaluate the scale, only control the text, the high text. Okay, and we can use, for example, in continuous, or we can use different format like DIN at A3, A2, etc. Continue, for example, like this. We can select different terrain to include in the same cross section. Okay, okay, I'm going to create a profile. Sorry, a cross section. And here is our cross section, our numerical data, and the slope in each vector, or something like that. Okay, to analyze our terrain. So in this example is a good example to create, for example, a civil engineer project to a reinforcement of this road. For this case, I'm going to hide the profile. To clean in this case, I'm going to design one road to follow the 16 road. I'm going to make a reinforcement of this road in order to shape the old structure of this road and only to create or to trench in both sides of this road to shape the earthwork. For example, we need to create one element here in MDT is the name is the segment. For example, segment here. We need to define the segment. Okay, this is the segment. I create just one. Alignment 2 is the same axis. And in this section, I link all the information, the alignment, the profile, the cross section, the grid line that I defined before, the template that I am going to use, or even the super elevation that we need to use. In this case, I copy the super elevation of the old road, and I select the same super elevation. So for this, I create that template to create the new road. Is this? I make one template or 7 meters of weight, and in this PK, in this station, I create one platform like this, okay, like a big footpath. For example, we need to remark here the road beds or the layer that we are going to use in our road. So, like I said before, I'm going to use a reinforcement. I define the line to define our reinforcement. In this case, are the line, the asphalt line in the old road. Is like this. Okay, so we can move along the road. Okay, we move to check how is our new road. We can define the ditch, the cut slope, the fill slope, if we use saving or if we have any wall or any structure, the geology, etc. In this case, I'm going to use the reinforcement. I'm going to use that polyline. If we have that polyline, I use this polyline to define this reinforcement. Only we are going to make a earthwork in both sides of the road. Okay, and here is. And when we have this, we are defining the layout, everything. Okay, we finish. We can evaluate our design. For example, we can check it. We can analyze point station by station of this element. For example, we can evaluate the head slope of the final earthwork, or maybe the different data of each line, or maybe the shoulder, evaluate everything. No, we can, for example, we can check the super elevation, and we have this control of the super elevation, how balance our road, our new road. It's a copy of the old road, the super elevation. Or maybe the grid line, we can check it. I make here one KV, around 20,500. Okay, and how to define all the road in this case. Okay. After that, we can create the final cross section. I have prepared in another draw, prepared yet. Or maybe we can make a volume report. If we click on volume report, the software make us the resume of the report of this data. It's very important to evaluate the volume of the earthwork that we are going to move. In this case, we can check the cut volume, the fill volume, the topsoil, if we define that, and we can say that. We can export a different format, Excel, or we can show in Word, or the draw, Excel, print, for example, the most common format to use that, no? To then pass another Excel or something like that to analyze all the data. Okay. I always this is the volume in the Excel. I export directly. So I always said that this window is very important because you can control everything in your rod from a little bit button, some button to control everything. Okay. If we click on and modify, we can move or create the new terrain with the modified terrain. So to avoid lose some time, some minute, I'm going to show the final result. Okay, I have here. Okay, and there is sorry. This is the final thing when we click on our rod. For example, I'm going to view. I'm going to clear the. I'm going to avoid the surface, and here is with the control line the new rod with all the weight and everything. Okay, so in this step, I forget to say that we can use one very common thing or useful thing is to use image from the website. In this case, I'm going to use image, insert. We can insert image from the one ortho image from the drone or something like that, that we have the coordinate of the photo center or something like that, or we can use the web map services map to use that image. In this case, I have the Slovenian ortho image. We are only to say the coordinate system, the reference coordinate system. In this case, this we can select different coordinate system of Slovenian. We have here the current coordinate reference system. Okay, and I'm going to select one window, for example. Next, I'm going to show that. And here it is. I'm going to select the ortho image. This cut of image saved in this name, no? In the folder of the work. For example, ortho. Okay. Download map. And here it is. This is our map in our work. So, well, I'm going to follow with the map. So I have evaluate how to work with this final thing. We can create, for example, some useful things like a surface, earthwork, to create esplanade or to create a pond or something like that. For example, I'm going to create one pond here in this area. For example, I'm going to click here. Sorry, F8. Okay, I'm going to create a basin right now. Close. Like that. For example, I'm going to create earthwork. Sorry, surface, earthwork. I'm going to use that command to create a pond, for example. In this case, I'm going to use terrain by elevation. I'm going to create here like a swimming pool, no? I'm going to use that polyline, and we can select that polyline. We are going to use the earthwork in this area. For example, we have this elevation to analyze. I'm going to use a subgrade, for example, 207 to create the depth of the basin. A useful thing is to get a target volume in order to evaluate the earthwork or balance the cut volume and the fill volume. In this, the first option, equalize both of them, or maybe we need to use one target cut volume or one target fill volume. We can select here, and the software start a cycling process to calculate the final elevation to get that target volume. Okay, right now we're not going to use. I'm going to create 197 elevation, the code, and go to create a turn pound. And this is the file where save the final surface, the final MDT digital model to work with this. For example, that we can create evaluate the calculable volume with we have this pound, for example. Okay, and here is this is our volume. Okay, if we have MDT with profile, okay, we have MDT control line is not done the pound. Sorry, I'm not sure what happened right now. So to show the final process, I create a virtual tool. For example, if you use, for example, virtual tool by terrain, in this case, to avoid to lose some minutes, I create here in this station, and we have the road and we have our pound. No? For example, create F6 T, and we can move around. We can move around our final terrain. Okay, because when we have imported the web from the ortho image from the website, we can delete, we can draw all the triangulation in our work. Okay, escape, yes. And another thing that we can use in this case is to export all the entity to Google Maps, for example. In this case, I'm going to use map render, export to entity to Google Earth. I'm going to select, the more important thing is to indicate the coordinate reference system, is this, the same as before. And now I'm going to select all the entity that I'm going to use to export. It's going to use that. I have a file to avoid to lose time to select the terrain. I have here the contour line, the mode, the surface modified. Okay, and okay. Click on OK. We are going to save in this file. Replace, yes, and open with Google Earth. Export to Google Earth. And here is our final road and our pound that we create in this example. Okay, even we can export all entity in Vim project. For example, MDT, Vim, export IFC format, and right now we can export the current surface or even the empty, where are all the entity of this surface. For example, the natural terrain that we have before. Here is open one visual viewer IFC. I'm going to shape here. Yes. And here is. And here is our project to evaluate in the Vim project work with this in another application with this kind of information. No? We can sell it here. Yes, and this is the basin. Okay, to evaluate in another project. Okay, pues I hope you like it, our demonstration, and if you have any question or if you have some more information, you can contact with us to solve anything. Okay, thank you for your attention.
Thank you, Antonio. Very good presentation, very good demo. I really enjoyed it. Everyone, thanks for your attention. Now it's time for questions and answers. Please don't hesitate in asking directly in English. Or if you prefer to do so in Slovenian, Primoz will be in charge of the translation of the question. So if anyone have any question about the demo, we are now 4 or 5 minutes here to respond, to answer all the questions you might have.
Tako, vkolikor želite, lahko dejansko vprašate direktno ali pa mene, pa v bistvu prevedem potem za njih v angleščino, ali se pa vprašanja podajo v chatu, tako da poskušamo na to odgovoriti, drugače smo pa itak dostopni potem preko maila, telefona, moje podatke pa tudi poznate.
Well, Primoz, I think there's no one who raised their hands. There's no questions. I don't know if maybe I'm wrong.
Vamos ahora con las preguntas. Vuelve y pregunta. There isn't any question. I see that there isn't any question, no? I hope you like it.
There are no questions, so I think everyone liked the presentation and everything was very clear. So once again, thanks for your time. Thanks, Antonio, for the nice demo. Thanks, Primoz, for the organization. And thanks, everyone, for attending this webinar of Aplitop TcpMDT on GstarCAD. If you have any further questions, you can contact us by email or through Primoz, our dealer in Slovenia. Thanks, everyone, and have a nice day. Bye.
Bye-bye. Have a nice day. Bye.